Hello, I'm Haziz by name, and I'm going to be working on some sort of data in order to show the autocorrelation and cross correlation of some set of data. Um, I'm going to be working on three data. There's the J17 data. J17 data is an aquifer data, and there's the Kumal. Kumal is a spring flow data, and there is the San Marcos. San Marcos is an San Marcos is also a spring flow. It's also a spring flow data. So I'll be doing some operations on this data in order to show the autocorrelation of each of the data. I'm also going to be cross correlating them two of the data each. So but autocorrelation. That's about autocorrelation. It's simply statistical method that is used to measure correlation between time series and lag version. So there's basically going to be a graph that shows the time and the lag time. It just shows how close related these data are over time. But to do that, I'm going to have some certain steps to take. The first is that I'm going to load my R Studio. I'm going to load the Zoo libraries, the XCS library, and the input library. And I'm going to go ahead to read the J17 file. I'll do the same thing for the Comal. I'll do the same thing for the San Marcos. And I'm going to create a zoo object from the water level elevation for um for the J17. In the case of the Comal and San Marcos, is going to be the discharge and with their corresponding date. And I'm going to also go ahead to check if there are some missing values in the data. And after that, I'm going to interpolate for missing water level values using using Karma sorting. And I'll perform a 10-day moving averages on the data. So I'll also aggregate the data to monthly value using the mean. So overall, the aim of this code is just to to clean and pre-process the time series data and to analyze the statistical to analyze its statistical properties such as the autocorrelation and cross correlation. So after using the ZooF, the ZooF simply shows a summary of the data, and this is a summary of the data. You can see this the mean. This is the mean. This is the first quarter. This is the median. The mean. The third quarter. This is the maximum of the data, and then the autocorrelation ACF is it's for the J17 shows that we'll see that there's a sharp drop. It's a sharp drop from the partial ACF from 1.0 all the way to minus 0.5, and then it goes to zero, and then everything seems to be around a constant average all to the head. The lag at 10, at 20, at 30, and at 40. So moving forward to the Kumal Spring Flow, after running the ZooF, this is what I have. This is the 612. That's the minimum. This is the fourth quarter. There's a median. There's a mean. The quarter, and then the max. So after running the autocorrelation, it seems to the Kumal data seems to have a similar um, autocorrelation time as 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 the J17 did, like the way it dropped sharply and then the way it slightly moved up and down around zero throughout the lag time and finally we I moved to cross correlation. So I happen to do cross correlations for cross correlations for the data. So in doing this, the first one to be cross correlated is this is, the the J17 data was being cross correlated with Komal. We can see that there seems to be like a sharp difference. Maybe this is due to the fact that the Komal data, the J17 data is actually has to do with height, um while the Komal data has to do with discharge. And on coming down to this is the Komal and San Marcos, we see something similar in the trend. But finally, coming down to comparing Komal and San Marcos, there seems to the trend seems to be about the same. They tend to move about the same all through the lifetime from minus 40 and to the end. And not to forget that I mean this cross correlation is just a mathematical method that we use to signal process to measure similarity between two signals. So it seemed like the Komal and the Samako seem to be similar, while there's a difference in between the G17 and the between G17 and Komal. So and let's not forget I want to show the R code. So this is the R code for J17. So this is loading the J17 libraries, the XCS, the input, and then um, give create talking about giving the directory to them and then extracting the date and changing the format of the date because the date format was quite different. And then I went further to check for missing values, creating objects, creating zoo objects of water level, creating a dummy object, then merging the zoo objects together, then plotting data to see if there's actually any visible periods of missing. And actually there wasn't any because no value came back. And then we interpolate for the missing value to see just in case we have any value that's missing. And we happen to plot for a 10-day moving average and the monthly mean of the data and the monthly data to see if there's just any visible period in which the data if there's no data. I mean, if to see that if there's like a break in the data, so that will signify if there's actually any time that is missing from the data. And then finally to the autocorrelation. And coming to the Comal, the Comal, the same process was actually being done from setting the directory to reading the CSV file, to checking for the missing value, to create a zoo object with water level, and creating a dummy object, merging the dummy object, plotting the data to see, and interpolating, calculate the 10-day moving area as we did earlier. And I think for this one, there also wasn't any missing value when we plot to see if there's any visible period in which there wasn't data. And finally, to the autocorrelation. So the same thing happened for the San Marcos. We did the same process, and here is the process for the autocorrelation. There I had to load libraries like the Lubridates, the Forecast, Zoo, the Input S, and the like. So this is just the process in which I took to come about the result for the autocorrelations and the and the cross correlation. So thank you.